All right, in the last video we talked about the basic calibration. In this video, I'm gonna do a quick overview of the advanced calibration option and also show you how to reset the sensor, talk about some other things. So first things first, if you wanna reset the sensor back to the way you get it from the factory, you have to push and hold the little button while you apply power. And you should hold it until you get the blink sequence. Okay, now we're back to calibration. And if we open the serial port, you should be able to see that we are back to getting the calibration data from the serial port. So we are not getting degrees or anything, we're just getting that. So put the sensor back in, okay? And to start the advanced calibration, if we want to do that, we start by doing a basic calibration. So go a couple spins either way, back and forth. The reason we need to do even the basic calibration, no matter what, is we have to tell the sensor what the highest and lowest magnetic readings are going to be. And it also tries to do some compensation for things like non-concentricity and other alignment issues, orbiting and stuff like that. So no matter what, when you design this into your robot system, make sure you can spin the magnet or your mechanism it fully through 360 degrees and be able to do it a couple times. Okay, now I've got the valid signal. Everything's happy, I've got a min-max. I could go to basic calibration, click the button once, and the sensor would start working. I wanna do advanced calibration, so I'm gonna do button click twice. And if I do that correctly, I should get a message on the screen. Now what this is telling me is to set my number of cal points. So briefly gonna attempt to explain this, and it can be hard to do without some graphics, but this sensor is absolute. It will say 0 to 360 degrees with respect to itself. That 0 and 360 degrees is always going to be repeatable, but it may not actually match true measured degrees. So say this is my 0 point back here, and I want to go to 45 degrees. If you don't do an advanced calibration, whatever number happens here will always happen there. Let's say for this example, it's 43 degrees. But if you really want that to tell your robot that that's actually 45 degrees and you've calibrated it, then the sensor gives you a method to do that. It's called linearization. It's pretty simple. The way it works is you store the actual positions into the sensor in any increment you want. The sensor supports 8, 12, 24, or 36 positions. This rig's set up for 36 positions, so that's every 10 degrees. And you tell the sensor, hey, this was actually 10 degrees, and it records those values. Then you go, this is 20 degrees, records them. This is 30 degrees. Then the sensor internally, when it goes back through and it's doing its calculation, will do a little, y equals mx plus b type of linearization between those points and give you better real world angle resolution. Now this sensor at its best is good to about 1 degree of accuracy. So perfectly calibrated with the perfect air gap and everything, that's probably the best you're gonna hope for on a repeatability basis. But now that we're there, first thing a sensor needs us to do is choose a number of cal points. So pressing the button will cycle through them. You can get 8, 12, 24, or 36. I'm gonna go for 36 for this example. I'm gonna press and hold the button now to launch us into the advanced calibration. And first thing it says is it wants you to pick a 0 position. Now remember, the 0 position can be arbitrarily changed at any point on the sensor itself. So for this, it's just a convenient starting spot for you to do your calibration routine. Oh, in this little rig, you can see I've set up a disc with 36 holes and a little spot to align it to. And this is just for our own internal testing, but you can imagine doing something similar on a swerve module, having holes or somewhere for a pin to line up if you needed to do it. And the way it works is, align your device however you're gonna do it, like I'm doing with the pin, then follow the prompts on the screen. So this says to press the button. Now after I've done that, it's moved on and said, okay, now you're gonna move it through all these different rotations and record the settings. So it wants me to go 10 degrees. So the first thing I would do over here on this rig, I would move my pin to the 10 degree mark, go into my alignment tool, hit the button, and if I press the button correctly, now the computer will tell me, okay, so I moved the rig physically 10 degrees and the sensor reported 10.73 degrees. So you can already see the first point in our calibration, we'd be linearizing between 0 to 10 in actuality be between 0 and 10.73. And I'll do a couple of these. I'm not gonna do them all. So now I'll go to 20 degrees. I'll put that in the 20 degree spot, push the button, and you'll see that when I press the button, it's now recorded the 20 degree position as 21.79. So the sensor thinks actual 20 degrees is 21.79, and that will linearize it. Now I'll go to the 30 degree, and we're not gonna go through all these, obviously. And I'll press the calibration button. Oops, so it recorded 30 as 32.67. So you can see right there, we got a couple degrees off already. Now you can imagine, walk through this, go through every position, and when you're done, you press a button and it'll jump into regular sensor mode. It'll retain that calibration unless you physically ever reset the sensor, and it should be good. And like in general, improves linearity of the sensor and makes it a little bit better. But in general, for 90% of applications, shouldn't be needed. But we have included that as an extra step.